In this example, we're going to be asked to find a minimum length, and it says two posts, one 12 feet high and the other 28 feet high, stand 30 feet apart. They are to be stayed by two wires attached to a single stake running from ground level to the top of each post. So where should each stake be placed to use the least amount of wire? Okay, so here we'll just call this the 28-foot high post, and we know that this is going to be staked to a point in the ground, and then we know the other post is going to be 12 feet high, and it's going to be staked to that same point. Now we know that the entire distance here is 30. Okay, now the amount of wire we're going to use is right here, and we're just going to let this one be Y and let this one be Z. And the only other variable we have here, it has to do with the distances. And you can probably see that we have two right triangles. So we're just going to let one of these distances be X. And that would be from here to here. And then the other distance is going to be 30 minus X to account for the entire distance here. So if we're looking here, our primary equation is a very simple one. So the primary equation is the length of the wire is going to equal Y plus Z. So what we need to do now is come up with secondary equations for Y and Z in terms of X. So looking at this, we're going to use Pythagorean theorem. And we know that x squared plus 12 squared equals y squared. And so here y is going to equal the square root of 144 plus x squared. And this becomes one of our secondary equations. And then we're also going to have to do one including z. So that's going to be over here. And so we get 30 minus x squared plus 28 squared equals z squared. And so let's go ahead and FOIL this. We get 900 minus 60x plus x squared. And then 28 squared is 784. And that's going to equal z squared. And so we just want to combine these and take the square root. So z equals the square root of x squared minus 60x plus 1684. And so here is our secondary equation, our second one. So let's go ahead and rewrite our primary equation now in terms of x using these two equations. So y here is going to be the square root of 144 plus x squared, and then plus z, which is the square root of x squared minus 60x plus 1684. Okay, so this is the guy that we want to minimize. Meaning we need to go ahead and find w prime. So I want you to pause the video, go ahead and find this derivative, and then come on back to check your work. Alright, so looking at this, you should have found your first derivative was this guy. And now, if you want to find the minimum value, we need to find the critical numbers. So we need to set this guy equal to 0 and then solve for x. So this is going to be a little bit of work. Go ahead and pause the video and give it a try on your own, and then come on back to see what you get for your critical numbers. Alright, so here is the solution. You can go through and see what happened here. We cross multiplied, and then I squared both sides. And then I went ahead and multiplied these polynomials together, multiplied here, and then I set it all equal to 0. And then I factored out the greatest common factor, which was negative 320. And then I factored this guy right here. It was 2x plus 45 times x minus 9. This part gave me negative 45 over 2, which doesn't make sense because we're looking at positive lengths. And this part gave me x equals 9, and so this is my critical number. Now our critical number was 9 here, and we're going to use a little bit of logic to help us out so that we don't have to do too much work here. So what we can think of is we could let all of the wire go all the way over here, and that would mean that x would equal 0 in this case. Or we could let all the wire equal here and let x equals 30. So we see that x can equal 0, x could equal 9, or x could equal 30. Instead of doing our first derivative test, we could actually just see what is our value here, here, and here. And since that is the only critical number on the interval, that we know the minimum value has to either happen here, here, or here. And so what we're going to do is we're going to test what is our wire length at this x value. Okay, so go ahead and substitute 0 in for x into our primary equation. Go ahead and plug 9 in for x into our primary equation, and go ahead and plug 30 into x for our primary equation. Then go ahead and come on back to check your answer and decide which value of x will give us the least amount of wire. Alright, welcome back. You should have gotten about 53 when x was 0. When x is 9, we get about 50 feet of wire. And when x is 30, our wire is about 60.3 feet. So if we're looking to minimize that, that's going to happen when x equals 9. So our minimum is that x equals 9 feet from the 12-foot pole. Okay, so when x is 9 feet from the 12-foot pole, we're going to get a minimum of about 50 feet of wire.